Renamer from the previous video is great. It does the job. It supports only 3 classes, but you could have implemented way more. The only thing, it's not data-driven. Implementing any new class requires copying old one and pasting it. And that's the amount of nodes for only 4 classes right now. What if we were supporting 20 of them? What if you wanted to change something? Or what if you forgot, like here, to connect the nodes? You will have to test all of those classes one by one, or your QA tester would have to. And it would be really easy to skip a single one, but very hard to implement a new one. So that's a very bad approach. And that can be fixed with data-driven approach. So this time we will use data table asset, and you will be able to add or remove supported classes at any time, and it would be so simple that anyone can do it. Data table is similar to Excel spreadsheet. It can even export or import JSON or CSV file, so you could actually easily export your data to Excel, Google Spreadsheet, or some other software and show it during the presentation and ask others if they like it without running Unreal at all. We can store various data in those, but this data has to be defined by a structure asset. Structure asset is some kind of, it's a schema or some definition of a container for our data. In our case, we will store class name, class type, and then the prefix. But in gameplay types of structures, you could store enemy name or enemy class and the damage or their health bar. So it really has lots of uses. So let's start with the structure, and then we will define the data table. Right mouse button in content browser, and I always struggle with finding it, so let's use the search here. Let's look for structure, create new one, and let's name it class prefix mapping. Double click to open the editor, and we already have some default value that we have to change. We are going to store class, so the name of our field is class, and now let's change the type. We need to find object, and then we are not gonna pick reference, which is like reference to existing object, probably loaded. Instead, we will pick class reference, reference to the class that the object is based on. And then let's add a field called prefix, and it will be just a string value. All right, let's save it. And now we can go back to content browser, right mouse button, go to miscellaneous and look for data table. But if you can't find it, can always search for it. So here we have data table, and we need to pick row structure. We already have created one, so we will be looking for this class prefix mapping. Press OK, and let's call it naming convention data table. Let's open it now, and here we can start adding new fields. They can be seen on the left side. You can always make those wider. And the first one is always a row name, so I will rename it with F2 on my keyboard to static mesh. Class will be static mesh, and prefix will be SM. And I will do the same for texture, material instance. And as you can already see, anyone can edit those, and it is really fast in editing. We don't have a general material instance picker, and now it's probably time to tell you which one you should pick. I'm gonna go with material instance constant, but you technically speaking could also think about material instance dynamic. They are two most popular kinds of material instances, but trust me, 90% of those we are working with are the constant ones. The difference is that material instance constant is once compiled and that's it, while the dynamic one can be still modified when the game is running. So when you are creating material instances and you are not doing such things on purpose, it is usually material instance constant. So that's already picked by me, then mi underscore, and we can make those even wider, and it seems pretty readable to me. I will save it. I don't need more examples than only 3 of those, but I guess you will populate it with many, many entries. Now we have to start making our tool. Right mouse button, editor utilities, editor utility blueprint, editor utility, the asset action one, and I will call it data-driven renamer. Let's open it. And as a first thing, I would like to create a new variable on the left side that will be a reference to my data table. So naming convention, and the type should be data table. We can pick it from here. It's going to be object reference. And on the right side, we have details. There is some default value field, but it's not available before compilation. So let me save, compile, and now we can search for this naming convention data table. And I will save and compile again, just in case I do something wrong, it maybe crashes. So I will already have this value set. We need a new event. So let me add a custom event. I will call it data-driven renamer. Make sure the call in the editor is enabled. You should be already used to enabling that. And now let's get selected assets, just like in the previous video. And now connect it to for each loop. Great. Now we need to do actual logic of our code of our node graph, and we will be iterating on each asset, but then we have to see if this asset fits to any class that is in our data table. So we can see what is available for those data tables, like what functions are available, and then think about the solution. So let's try adding a new node here, and we can scroll down to data table, and you can see there isn't a lot. There isn't anything that would return us an array or a dictionary where we would have everything done. But we can get row names, and we can get specific row by referring through the name. So there is this get data table row names, and that will return us array. So we will have to iterate over those with another loop, but we will eventually be able to see if my asset is the class from the first row, is it the class from the second row, is it of the class of the third row, and so on. So eventually we will be able to see if it fits to any of our data table rows. So we have this get data table row names. We have this naming convention data table, and we will need another for each loop. So let's connect those together. And then from our data table, I will create another node, and it is get data table row. And the row name is going to be an array element. We need to connect this loop body. And if we wanted to, we could print all of those right now. But if we want to get only the class or only the prefix, we have to figure out some way of working with this output row that is here and getting it. Because this is some struct, but we have no idea what type it is. But on the other hand, as creators, we know what kind of data table we have been working with, and we know that it uses the structure defined by us. So we can make something like break struct, and there is a lot of those, and we have to find a function that correlates to the struct we made before. And our struct was called class prefix mapping. So we can try break class prefix mapping, and we were able to find it. When we connect those, Unreal no longer treats it as a wildcard. It still does, but it finally will know what to return us. And when it comes to this node execution flow, we are iterating over existing names. So there is no chance we would have a case where specific row doesn't exist. So for that reason, we will always have this row found execution and never row not found. So we don't have to worry about it. So right, now we have a way of getting the data from the table, and we have to make use of it. So each time we process an asset, we will go through this loop, and then we will see if our asset is the same class as the data row class. And to get this class, we have to find reference to our array element and use getClass function. It is in utilities section, and now we can just compare if they are equal. So let's look for equal. Let's connect this class here. And now we have true or false value that can be used in a branch. Let's connect it. Let's also connect this execution to found row. And now, if we are not working with the asset that is same type as this class in the data row, nothing happens. So we don't care about this false result. But if it is true, we have to see if the naming is correct. So we can get the display name of our array element. Nice, we have the display name, and we will check if it starts with, and this time we are not hard coding anything like t underscore because we have it in the struct mapping. So we take the prefix from here, and for easier organization of the code, you may want, for any reason, to reroute this link here by double clicking on it, and now you have another node that has no feature, but will let you make the graph nicer. So that's in case you want to make it more handy. So now we know if it starts with correct prefix or not. And if it's not correct, we want to use branch again. And if it's not correct, we will fix it. So rename asset. And as in the previous video, I used the wrong rename asset node. So let me search for it again. We want the one from editor tab because it expects an object. And we will connect it to this array element. And now the only thing left is to create a new corrected name. We have the prefix, we have the display name. So let's use an append node to concatenate those together. And we are done. I know there is a lot of routing coming from this left side of the screen. If you want to use temporary variable for current asset or for the name, feel free to go. But This is simple enough and doesn't require more copying and pasting that I will not do anything else about it. But feel free to go. You may want to start introducing more features, and probably having it cleaner will help a lot. So now I will save it, compile, and I would like to test it. If there are any errors, we will fix them together. Let me copy a few test assets from right to the left side. And as in the previous video, one of them already has SM prefix and others don't. So let's select them, right mouse button, scripted asset actions, and let's run data-driven renamer. And all of them are now named properly. If any time you would like to change the naming, you can go back to your data table. We can rename static mesh to maybe fancy mesh. Hit enter, save it. Maybe let's try it on something not renamed yet. And all right, let's run it on this again. Now it is fancy mesh, but remember this SM prefix now stayed. And if you want to change naming convention from one kind of prefix to another, then I would recommend you to create a separate tool for that and keep them granular and simple. So to sum up, you just learned how to make your tools more data-driven and how to work with data tables. See you.